We're going to now talk about the addition of two vectors and what it means to do the operation of A plus B and ask whether that equals a third vector C. Because vectors have both a magnitude and a direction, we'll think about this plus sign as having a somewhat different meaning than it just means in algebra class, where I take 5 pounds and add 2 pounds and get 7 pounds. We're going to mean now by addition the succession of two operations, where I first travel in a direction given by A, and then from there go in a direction by B, and say, what is that equivalent to? This is the vector C. Notice that it's not the case that A plus B equals C. That's not true. If you mean by A, B, and C right now, the lengths, in this picture, that length plus that length is much more than this length of C. So we don't mean the same thing at all when we put a plus sign here in a vector addition sign. This vector addition means the successive translation by that amount and direction plus this operation of doing that translation by that amount and direction. And the sum of A plus B is this new vector C. So for example, if you were talking about displacement, like how many meters did you travel, your net displacement might be only 5 meters here, even though you might have actually had to travel 5 meters that way plus 5 meters that way. In other words, your odometer would have rolled off 10 meters, but your net displacement might only be 5 meters because that's the vector sum. There's some important facts about this kind of addition. It's what we call commutative. In other words, A plus B, the vector sum, is equal to B plus A. And it's associative. A plus the combined sum B plus C is equal to A plus B sum together first plus C. In other words, it doesn't matter what order of operations you do. Another important fact is that a negative vector can be defined minus A is the vector A plus this minus A equals 0. Which immediately tells us that if A goes like this, then minus A points backwards, is parallel to and has the same length as A, but it points in the reverse direction. Sometimes that's called anti-parallel, so you might see that terminology as well. But the fact that we would like this kind of vector addition to work, A plus B is equal to C, the 0 vector is one that has 0 length. So whatever we would add to A has to give us back 0. So it has to point backwards along the length of A, or be anti-parallel to A. So this, in a graphical sense, gives us some notion of what vector addition is supposed to do, but now we have to develop the mathematics to actually achieve this kind of goal. So how do we actually do vector addition in terms of mathematics? Well, if we would like to compute the sum of A plus B, and A is defined as this ordered pair AX and AY, and B is this ordered pair bx and by, it's helpful again to think about our coordinate system. So here might be the xy plane. And A might look like this. And B might look like that. This length right here is equal to AX. This length right here is equal to AY. This length right here is BX. And this length right here is BY. So we're looking for a new vector, C, such that it would be the sum of A plus B. And how do we compute the coordinates of C? Because remember, every time we can find an xy pair, then it specifies this new vector. Well, Cx, if you can just look at what must be the projection of C down the x-axis, it's none other than AX plus BX, and Cy is AY plus BY. And the length of C, in other words, the absolute value of C with the arrow on it, is equal to the square root of Cx squared plus Cy squared. So all of this information can be found from the original components AX, AY, and BX, BY. And then we can learn everything we need to know about the vector sum. It's important as we think about doing these kinds of additions that sometimes vector components can be less than 0. So this is the y direction, this is the x direction. Suppose my vector is A, and it looks like that. AY is right here, but AX is over here. Along the x-axis, that's AX, and it's in the negative x direction. Thought of another way, this angle phi is more than 90 degrees. And so when I go and compute AX, which is the magnitude of A, times the cosine of phi, that's going to be less than 0. And in this case, AY, which is A times the sine of phi, would be greater than 0. It's also possible to have this vector point down here in the third quadrant. So this is first quadrant, second quadrant, third quadrant, fourth quadrant. Over here in the third quadrant, both x and y components are negative. Here's a simple problem that we can try to compute. If we drive 2 kilometers straight east, then turn 60 degrees in the northerly direction, and then drive an additional 4 kilometers, we can ask, what is our net displacement? It's easiest if we draw a picture of this. I'll draw a 2 kilometer vector that would look like so, and then a 4 kilometer vector, so something twice as long. And since we had to turn directions, there has to be an angle between the old vector and the new one of 60 degrees. And we're asking what's our net displacement. We're not asking how many miles we traveled. That would be 4 plus 2, in other words 6 kilometers. We're asking for the net displacement. In other words, this new vector C And we find Cx from ax plus bx. Well, ax, if this is a, and this is b, a is only in the x direction. So this is my little coordinate system. A is only in the x direction as I've drawn it. So this would be 2 kilometers. B is a little bit in the x direction, a little bit in the y direction. So I'd have to put 4 times the cosine of 60. And it turns out cosine of 60 is exactly a half. So this actually equals 4 kilometers, because 4 times a half is 2, and I add another 2, and that gives me 4. C sub y is equal to ay plus by. Well, a sub y, this vector right here has no y direction, so its component is 0. And b sub y is 4 times sine of 60. Which is about 3.4 kilometers. And the magnitude of c would equal the square root of cx squared plus cy squared. And this equals about 5.3 kilometers. So even though you had to travel 2 kilometers plus 4 kilometers equals 6 kilometers, your net displacement is only 5.3 kilometers.